Sushruta for NEET is now available on the Google Play Store. Try it out for free.
Hi, my dear students. Hearty welcome to biology class of JnanaMarga and Urea combined. I am Prof G.K Bhat. With reference to environmental issues, we shall in today's class deal with the agrochemicals and their effects and further. You know, we people extensively use inorganic fertilizers to get high yield. Every farmer is bent upon getting as much yield as possible. Does not matter how much inorganic fertilizer he is putting into the soil. In the wake of a green revolution, use of inorganic fertilizers and pesticides has increased manifold for enhancing crop production. I hope you have heard what is green revolution. Prior to green revolution, the farmers were using more of organic fertilizer. They used to have compost pits. They used to collect this cow dung from their cattle shed, put into the pit containing the greeneries, leaves and all. And they used to have these organic manures, and that organic manures were extensively used for agriculture purpose. No doubt, the yield was never comparable to the yield that was obtained by the use of inorganic fertilizer. During Green Revolution, or as a result of Green Revolution, farmers turned to extensively use this inorganic fertilizer, and they learned that by using inorganic fertilizer more and more, they could get a better yield when compared to that of organic fertilizers. And also they learned to use these chemicals to just get rid of the pests, what you call pesticides. So, in the wake of Green Revolution, use of inorganic fertilizers and pesticides has increased manifold. Pesticide has increased manifold for enhancing crop production. So to see that our crops are not damaged by these insects or by fungi, we were extensively using these insecticides, pesticides, fungicides, etc., etc. Pesticides to get rid of unwanted creature, what you call pest. Herbicides to get rid of unwanted herbs. Fungicides to get rid of unwanted fungal members, etc., are being increasingly used. These incidentally, you must remember, are also toxic. Whenever you use insecticide, this insecticide not only kills the insect, whatever we don't want, but also these insecticides kill the insects which we want, or which are not at all harmful to our crops. So these incidentally are also toxic to non-target organisms. Non-target organisms are the one which are not targeted by us to kill. We wanted to kill only those organisms which are harmful to our crops, but not all. So whenever we started using extensively these insecticides, pesticides, herbicides, fungicides, etc., not only they used to kill that unwanted creatures, organisms, but also they used to kill non-targeted organisms. They used to be toxic to non-targeted organisms that are important components of the soil ecosystem. Now let us think that you are applying some chemical to get rid of one particular type of insect which is creating problem to your vegetable plant. Suppose there are good number of earthworms there in the soil. You know, earthworms are farmers' friends. Is it not that when you use you use this insecticide or spray this insecticide to kill the insect? Is it not that the same insecticide is going to create problem to earthworm? That is what you say. Here, earthworm is a non-target organism. Insect is the targeted organism. So therefore, whenever we use these chemicals to kill this our target organism, they become toxic to non-target organism that are important components of the soil ecosystem. Okay? Kavita,
Yes, sir.
have you understood this?
Yes, sir.
Okay? Now, do you think these can be biomagnified in the test ecosystem? That means whatever you put, is it not that it goes on increasing in the quantum in the soil? We know that. What we know, what the addition of increasing amounts of chemical fertilizer can do to aquatic ecosystem, vice versa, eutrophication. What is it vice versa? Eutrophication. You know, eutrophication, you have already heard about that. Can you tell me what is this eutrophication? Anyone? Kanisa, Rafa? Can you tell me what is this eutrophication?
Natural aging of the lake by nutrient enrichment.
Okay. It is the natural aging of the lake by nutrient enrichment. That is true. Eutrophication is also that it is enrichment of the lake with more and more addition of nutrients, which results in increase in the organic mass also. The current problem in agriculture are therefore extremely grave. Why? Because we are using extensively chemical fertilizer, and these chemical fertilizer, what happens during rainy season? These whatever chemicals you use in your cropland, whenever it rains, the rains washes away these chemicals which are extra there, which are not absorbed by the plants into nearby water source. So nearby water animals, what you call aquatic animals, they also get affected. Aquatic ecosystem gets affected. Case study of organic farming. Let us see how people used to manage and used to do their own way of organic farming. It is not that whatever we are doing is new. There are many people at a different time period. They all tried different ways of different types of agriculture system. Integrated organic farming. Integrated organic farming is organic farming. Organic farming is farming done with the help of organic nutrients. Integrated means good number of people joining together and making, or one particular person going for different types of crops. Integrated organic farming is a cyclical, zero waste procedure where waste products from one process are cycled in as nutrient for other process. Please remember, this is always ask a question. What is integrated organic farming? Integrated organic farming is one where a farmer goes to cultivate different types of crops. One crop, in one crop, whenever he goes for one crop, he gets the yield from that crop. After getting the yield from the crop, there will be lot of crop residues. For example, with regard to paddy, once you harvest the paddy, once you get this paddy and use it and make rice from that, the straw of the paddy or the roots of the paddy, it gives you the rice, the paddy, straw of the paddy or roots of the paddy, yeah, is considered as a crop residue. So once you harvest urdu dal, black gram, or Once you harvest tur dal, what you call togri bele, pulses, after harvesting these pulses, the entire plant with the leaves, stem, roots, etc. is considered as a crop residue. This crop residue can be used to manufacture or to produce organic manure. What has to be done? The crop residue, that is the left out part of the plant, after getting whatever the grains that we wanted to. So after getting that, these left out portions of the plants are dumped to pit. To the same pit, this cow dung is put, and thereby this particular that crop residue is made to undergo decomposition, and thereby the organic manure is produced. So this is what you come across. So integrated organic farming is a cyclical zero waste procedure where waste produced from one process are cycled in as nutrient for other processes. This allows the maximum utilization of the resource and increases the efficiency of production. Maximum utilization of resource. So nothing is thrown out. If at all you are going for sugar cane, you take the sugar cane, you use the stem part of the sugar cane to extract this sugar or jaggery. At the same time, the leaves and the root part, etc., they can be used as used to prepare the organic manure. Ramesh Chandra Dagar, a farmer in Sonipat, Haryana, has done a good business. What is that? The other includes beekeeping. Look here, he has not gone for only monocrop. Monocrop is only going for one crop. What this gentleman has done, he started going for beekeeping, dairy management, water harvesting, composting, and agriculture in a chain of processes which support each other and allow an extremely economical and sustainable venture. And it is not only Dadar, even if at all you just go to the Malnad area, in many of the estates in Malnad area, if you just visit Koppa, Sringeri, Balevanur, Jayapura, or go to any estate, any of these estates in Markera, or go to any estate in North Canara, like that, Kumta, Shirchi, there, you see that people, agriculturists, the farmers, they never go for only one crop. If you enter their arecanut garden, you will see along with the arecanut garden, there will be cardamom, elaki will be there. You know, cardamom is elaki. And some people will be having this coconut, some people will be having the coffee, some people will be having the banana. That all this, even coconut, all these will be there as a mixed crop. So even if at all one year, the arecanut that here, arecanut, whatever the residues that you get from the arecanut plantation can be used as a manure for coffee. Whatever you get from the coffee or banana can be used as manure for that cardamom, like that. So this is what is done. So there is no need to use chemical fertilizer for crops as cattle excreta, dung are used as a manure. So you don't know how much the benefit we get from cattle. Each and everything that we get from the cattle is of quite useful to human being, right? Including its urine. Crop waste is used to create compost, which can be used as a natural fertilizer or can be used to generate natural gas. You know, cow dung is used to get the that gas for cooking purpose, lighting purpose, etc. What you call biogas, gobar gas. So generate natural gas for satisfying the energy needs of the farm. Enthusiastic about spreading information and help on the practice of integrated organic farming, Dagar has created Haryana Kisan Welfare Club with a membership of 5,000 farmers in 2006. Not now, 5,000 farmers at that time. By this time, it might have crossed 5 lakh. Understood? You have any doubt? Nadira,
Yes, sir.
you got? No. Diti,
Yes, sir.
you have doubt?
No, sir.
No. Siddesh,
No, sir.
Rakesh,
No, sir.
Vishwita,
No, sir.
Tanusri.
No, sir.
Now, let us look into the next one, radioactive waste. Initially, nuclear energy was hailed as a non-polluting way for generating electricity. Even nuclear energy was used as a source of generating electricity. Later on, it was found that the use of nuclear energy has two very serious inherent problems. What are the problems? When the nuclear energy was used, or people, the managers, policy makers decided to have nuclear energy as the source of power at Kaiga. It was one of the great author, who got a Jnanapita award. He objected it to tooth and nail. Anyone has the idea? Who was it? Anyone has the idea? Who objected this? He objected the project to be started at Kumta, that particular area, in Kaiga area. And he was very good. Who is telling this? Can it, sir?
Yes, sir.
Very good. Star of the day. It was a Shivaram Karan. He opposed it, telling that there will be serious problem on the health of the people in the days to come. Lot of people supported him at the beginning. Later, what happened, He contested election. And in election, people defeated him. People did not vote. Even though he tried his level best to fight for the cause of the people, for the future of the people, he was not got elected. Anyhow, this is the case. People never bother about that. Who is doing good work? Who is doing bad work? So, here, nuclear energy was considered as one of the non-polluting way of generating electricity. But later, it was realized that the use of nuclear energy has two very serious inherent problems. What are the problems? One, the first is accidental leakage. We should be 100% guaranteed that there will not be accidental leakage. Suppose the leakage happens, what next? What next? To think what next? The people will not be there alive. Where we have these nuclear plants, the problem will be there for the people who are living in and around that. You can think about a solution if you are far away from that place. But whatever the people living there, I hope in 1984, in December, one incident happened. Do you remember where it was? What it was? 1984 December. There was a sudden unexpected leakage of potassium isocyanate. Where it was? What is that tragedy called? Anyone? Anyone? Is it potassium isocyanate, methyl isocyanate? Have you heard about this, Prithvi?
Yes, sir.
Methyl isocyanate.
Methyl isocyanate. Where it was, Vismita, it is your voice, am I right?
Yes, sir.
Yeah, yes, sir.
Sir,
Where
was it in Bhopal?
Yeah, it was Bhopal. Bhopal gas tragedy. Thousands of people suffered. Thousands of people became impotent. Hundreds of people died. Thousands of people got health problem because of the leak of the methyl isocyanate one day fine morning. What happened? People who suffered. And the person who was responsible for that, a foreigner, CEO, one fine day, he flew away. He should have been jail. He should have been in our jail. But because of one of the ex-prime minister, he just flew away from India, and even the sufferers, victims, are still suffering in India. So, coming back to radioactive waste, the first is accidental leakage, as occurred in the 3 Mile Island and Chernobyl incident, and the second is safe disposal of radioactive waste. One, preventing accidental leakage. Two, safe disposal of radioactive waste. Where you put them? Where you dump them? Even if you dump them, there will be leakage from there to the nearby drinking water. What you do? This is the problem. Then, of course, you need not, there is no more information on this. I don't want to give because I have to go fast. 3 Mile Island and Chernobyl incident. Chernobyl, you might have heard now, recently in Ukraine war, Chernobyl is there in that particular place. They see that there is again a leakage of the radioactive elements. Okay, so this is what you have. So just to have, this is the 3 Mile Island nuclear power plant, and it leakage from here, it has affected several thousands of people. I don't want to go through that. Okay, then this is the Chernobyl disaster. Look here, what has happened to that? So this has made the people to suffer, right? Okay, now, okay, I have to take up, yeah, I think here. Am I right? Radiation that is given off by nuclear waste is extremely damaging to organisms, including human beings, because it causes mutation at a very high rate. So always it is very unsafe to live near these nuclear plants. At high doses, nuclear radiation is lethal, but at lower doses, it creates various disorders. At high dose, it is lethal means it brings about the death. Lethal means death. At high doses, nuclear radiation is lethal, but at lower doses, it creates various disorders, the most frequent of all being cancer. We don't know now why the cancer comes, the root cause of cancer. So for many of that, the cancer is due to many, many different reasons. So this is one of that. Therefore, nuclear waste is an extremely potent pollutant and has to be dealt with utmost caution. So whenever we are using this nuclear energy as a source of power, we must be careful. On one hand, it is the leakage. On the other hand, it is the safe disposal of this nuclear waste. It has been recommended that storage of nuclear waste after sufficient pre-treatment should be done in suitably shielded container buried within the rocks about 50 meters deep below the earth's surface. Where you have to go? You have to go in search of the rock, not the soil. If it is put in the soil, from there it may leak further down. You have to go in search of the rock. In that rock, there should be about half a kilometer deep. You have to go and you have to put it and cover it. But is it safe then also? However, this method of disposal is meeting stiff opposition from the public. Where will you put? You have to put on the earth only, no? If you put it Udupi, Mangalore people will object. If you put it Mangalore, Udupi people will object. Where you are going to put it? Because at any time, leakage may take place from here. So, this is the thing. Now, let us look into the another concept, greenhouse effect and global warming. Very, very important for board exams, of course. It is in your deleted portion. Very important from the NEET point of view. Greenhouse effect. Very important from our day-to-day life. What is this? The term greenhouse effect has been derived from a phenomenon that occurs in a greenhouse. Have you, any one of you, have you visited the greenhouse anywhere? Anywhere? Any one of you visited greenhouse? Come on. I can't see. If it is raised your hand, you have to orally tell. Yes, sir. I have seen. I had been. I have entered. Have you entered the greenhouse? Any one of you? At any time? Rafa,
Yes, sir.
have you entered?
No, sir.
No. Rakesh,
No, sir.
Chinmayi,
No, sir.
Vishwas, Prithvi,
No, sir.
one should enter. Fortunately or unfortunately, I got an opportunity to enter there. We did some farming in about half an acre of the greenhouse. We grew inside this greenhouse capsicum. Do you know what is a capsicum? Isvita, Nadira, Jayasri. What is capsicum?
Yes, sir.
Capsicum is? What is that Kannada?
Dabbu ಮೆಣಸಿನಕಾಯಿ.
Yeah, Dodne Mensinkai. This is big. Have you seen Isvita? No. Isvita, are you there?
Yes, sir.
Yeah. So this is the capsicum. It comes in a red color, yellow color capsicum, green color, normal capsicum. We did that. We harvested it. And if you enter the greenhouse, within 15 minutes you feel like coming out. You can't. What is the concept of greenhouse? Greenhouse allows the light to come in, but it does not allow the heat to radiate out. That is the concept. It allows the light to come in, but heat is not allowed to radiate out. So therefore, you can imagine what will happen if it will enter into the greenhouse. You will literally sweat. So why this arrangement is done? The term greenhouse effect, whatever we are telling, is the same thing. Now, you might have heard about when you are feeling very much hot, now and then, people start telling about this effect of global warming, global warming, global warming. Am I right? Am I right? You start telling global warming, global warming, global warming. Am I right? Yeah? Yeah? So this is the effect of global warming. Greenhouse effect. What is that? We get unexpected heat. It looks like a small glass house and is used for growing plants, especially during winter. During winter, by nature, you know, during winter, the plants, they do not show much growth. Growth is always retarded during winter, but accelerated during spring and summer. So, greenhouses, crops in the greenhouses are mainly grown during the winter. During it, light is allowed to come in, heat is not allowed to go out. So the plants get a little bit more warmthness to grow better, right? So this is what you have the greenhouse. Can you see here? You feel so nice. You will get fried the moment you remain there. You feel like coming out. But imagine the farmers who have to work there for hours together by staying inside, right? Definitely, there are many advantages. You will not come across any insects inside that much easily. You will not get any pests also, but it has its own problem. That is different. We realized it. We got very good yield, but when we got very good yield, we used to get every alternate day to the extent of 2 to 3 tons of capsicum. How much? How much kg? How much kg? How much kg? 2 to 3 tons of capsicum alternate days. How many kgs? Rafa,
Yes, sir.
how many kgs? How many kilo? 3 ton, 2 ton. 1 ton is 1000 kg. 2 tons, 3 tons means 2000, 3000 kg. Whenever we used to get that much of yield, remember, whenever that market rate was 200 rupees per kg, imagine how much they might have offered for us, the middlemen, those who are there to take that to market. You cannot go and sell that market on your own. You have no permission for that. You have to sell it to the person, middleman. How much they might have offered? Imagine. Navya, Janani, imagine how much they might have offered us per kg. Market rate was 200 per kg. If you go to market and if you want to get this capsicum, you have to pay 200 rupees. And this growing agriculturist, how much they might have offered? A guess, Prithvi, Rakesh, Siddesh, Vishwas, guess how much we might have been offered per kg? Hello, are you following me?
100, sir.
Who is telling? Can you, sir?
Rafa.
Rafa?
Rafa.
If they give 100, happily would have given to you. Happily. You may feel it unbelievable that they used to offer us 12 rupees per kg. How much? 12 rupees for growing this, for paying the labors itself. It used to come to us the cost of 45 rupees per kg. Where is 45 rupees expense? Where is the market rate of 200? And where is the grower getting 12 rupees? And whenever you see, you hear that the people pouring their tomatoes on the road, a truckload of tomatoes on the road, you may think, you might have thought that what a foolish people. Am I right, Kanisa? Have you not read in the newspaper? Have you not felt like that? What is people throwing tomato on the road and going? Tons together? Foolish people. Am I right? Kanisa is not there. Not
I'm
hearing
there,
the
sir.
lecture. Hearing lecture. So this is what's happening. Therefore, this is what the farmhouse. Remember, agriculture is a different topic. I'll tell later. In a greenhouse, the glass panel lets the light in, but it does not allow heat to escape. This is what I said, greenhouse. What it happens? It lets the light in, but it does not allow the heat to escape. Therefore, the greenhouse warms up. Inside the greenhouse, the air warms up, very much like inside a car that has been parked in the sun for a few hours. Navya, Navya, Navya,
Yes, sir.
have you ever tried to enter the car which was parked in very bright light in midday to enter there and to sit? Have you
Yes.
got, have you got the experience of that?
Yes, sir.
Same experience is in a greenhouse gas. Greenhouse warms up in the same way. The greenhouse effect is a naturally occurring phenomenon that is responsible for heating of Earth's surface and atmosphere. So, whatever you heard about greenhouse, whatever I said, greenhouse, what is that? Tanusri? 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 What is happening in the greenhouse? What is let in? What is let out?
Light is letting sun in.
Light is let in and
Heat is
heat
back.
is heat is let out?
No,
No. Light is let in, but does not allow heat to escape. So the same thing is happening in nature. The greenhouse effect is a natural phenomenon that is responsible for heating of Earth's surface. Remember, it is responsible for heating of Earth's surface and atmosphere. That means the light is allowed to come in and heat is not allowed to go out. So as a result, H, you come across global warming. You would be surprised to know that without greenhouse effect, now isn't it greenhouse effect is good or bad? Look here, without the greenhouse effect, what is that greenhouse effect? What is the greenhouse effect? Allowing the light to come in, does not allowing the heat to escape easily. Without such a greenhouse effect, the average temperature at the surface of Earth would have been minus 18 degree rather than the present average temperature of plus 15 degrees centigrade. The temperature would have been minus 18 degrees centigrade. If the temperature would have been minus 18 degrees centigrade, you cannot expect anything to remain. So, little bit of that greenhouse effect is required. In order to understand the greenhouse effect, it is necessary to know the fate of energy of a sunlight that reaches our outermost atmosphere. Let us see what is happening, how this greenhouse effect is brought in. How this greenhouse effect is brought in. So greenhouse effect is keeping the temperature of the earth at a somewhat constant condition. Greenhouse effect is allowing the light rays to come in and not allowing the light rays and allowing the temperature to escape that much easily. Okay, now let us see what's happening. Look here. Look here. You see here from the sun, rays to come and touch the earth surface. What happens? They tend to go back. But what happens? The greenhouse gases, whatever gases are present there, they make it a point to get it back, to strike back the earth, So greenhouse gases, see, these are the greenhouse gases, whatever you come across here, these are the greenhouse gases here. Greenhouse gases absorb long wave radiation, long wave infrared. Long wave radiation is always infrared. Absorb greenhouse gases, absorb long wave infrared radiation from the earth and emit it again towards the earth. Emit it, absorb and emit it. Absorb this absorption and emit it again towards the earth. The cycle continues till the earth's surface has no long wave radiation to emit. No long wave radiation. So, therefore, to certain extent, greenhouse effect is required. But whenever it crosses beyond, then only it is problematic. Clouds and gases, very important point. Just listen to me now. What you see, the long waves here from the sun, the long waves, what did come? The long waves that are absorbed by the greenhouse gases and they are emitted back to the earth's surface, thereby keeping the surface temperature on the earth generally around 15 degrees centigrade. This is what. So, clouds and gases reflect about 1/4 of clouds and gases reflect about 1/4 of the incoming solar radiation. Clouds and gases will be there on the Earth's atmosphere. Clouds and gases will be there. Okay, clouds and there. These reflect about 1/4 of the incoming solar radiation, absorb some of it, but almost half of incoming solar radiation falls on Earth's surface. Only half of that falls on the Earth's surface, heating it, while a small proportion is reflected back. About 50% solar radiation strikes the Earth's surface, heating it. And from there, a small proportion is reflected back. Earth's surface re-emits heat in the form of infrared radiation, but part of this does not escape into space as atmospheric gases absorb a major fraction of it. So, it is the gases, whenever you say gases are there, gases include carbon dioxide, atmospheric gases, carbon dioxide, methane, these absorb major fraction of that heat radiating from the Earth's surface. Right? Now let us see further what is happening at what level. Therefore, please remember one point. whenever that radiation comes from the sun, it strikes the earth surface. After striking, it gets reflected back, and that radiations are again they are caught and reflected because of this carbon dioxide, methane, etc. present in the atmosphere. Look here, the molecules of these gases radiate heat energy. Molecules of these gases, which gases? Which gases? I'm asking you all this again. Carbon dioxide, methane radiate heat energy, and a major part of which again comes to Earth's surface, thus heating it up once again. So, carbon dioxide and methane, whatever is there, these reflect back some of the waves, and that these gases radiate heat energy, and major part of which again comes to the Earth's surface and thus heating up again. This cycle is repeated many a times. The above mentioned gases, which are all carbon dioxide, methane, are commonly known as greenhouse gases because they are responsible for the greenhouse effect. So, whether we want it or not, question, carbon dioxide, methane, come on, whether we want it or not. Kanisa? Hello? Are your people are following me?
Yes, sir.
Whether you got Vismita, whether you got it clear or you have doubts?
Sir, it's clear.
Nadira,
Yes, sir.
Lohit,
Yes, sir.
look here. This is what you have, the greenhouse gases. 60% of the greenhouse gases is, very important, carbon dioxide. 20% is methane. 14% is CFC. What is CFC?
Chlorofluorocarbons.
Chlorofluorocarbons. And 6% N2O. So this proportion is relative contribution of various greenhouse gases to total global warming. If you look into that, this proportion, if at all it increases, that results in more and more global warming. To a certain extent, they should be there. If these are more and more reflection will come. Heat gets reflected more and more back on the earth. That is going to create problem. Some amount is required. If they are not there, then there's a problem. If they are there in a moderate amount, no problem. If they are present more, then there's a problem. So, increase in the level of greenhouse gases, that is a problem. Increase in the level of greenhouse gases, moderate level, no problem. Increase in the level of greenhouse gases has led to considerable heating of Earth, leading to global warming. So whatever this carbon dioxide, methane is there, whenever that heat gets radiated back from the Earth's surface or to the atmosphere, if that should be reflected back to the Earth, otherwise our Earth will be about cool by minus 80 degrees centigrade. Now, if at all it is about plus or minus around 15 degrees centigrade or 20 degrees centigrade, it is because of these greenhouse gases. During the past century, the temperature of Earth has increased by 0.6 degrees centigrade, most of it during the last 3 decades. You know, now summer is very hot. Not only summer, even during other time also, we find this warmness at different seasons of the year. Right? Scientists believe that this rise in temperature, global warming, is leading to deleterious changes in the environment and resulting in odd climatic changes. You must know El Nino, La Nina. I will tell you about that. You have to take down later. So there is a peculiar phenomenon called El Nino effect, La Nina effect. What is this El Nino, La Nina? El Nino is warming. La Nina is cooling. So this is appearing very now and then. Scientists believe that this rise in temperature is due to increase in the level of carbon dioxide and methane in the atmosphere. It's leading to deleterious changes in the environment, resulting in odd climatic changes. You expect Earlier, you used to come across a distinct season like rainy season, winter, summer, and all. At Udupi and all, forget about Bangalore. At Udupi and all, during this December, what you used to find? Navya, what you used to find during December? Rafa, Kanisa, Janani, what you used to feel during winter? Whether you used to feel cool or whether you used to feel warmth or rain and what else?
Cold, sir.
Yeah, we used to get a very cool temperature. You used to feel a little bit chilling cold. Am I right? But is it that nowadays you feel that? Navya?
No, sir.
No. This is what you say. All the climatic changes, even at Bangalore also. Namrata, are you finding the same type of cold in Bangalore?
No, sir.
No. These are the climatic changes, thus leading to increased melting. This what happened? El Nino, warmthness, or the climatic changes, thus leading to increased melting of polar ice caps. Remember, these polar ice caps to get formed, it took several millions of years. Several millions of years have resulted in the formation of polar ice caps, such huge ice blocks in the polar region. But now we see that they are getting melted year by year. They are getting more and more melted, thus leading to increase in melting of polar ice caps as well as of other places like the Himalayan snow caps. Himalayan snow caps. You know, those who live nearer to Himalaya, some of these mountains, if you at all you look into the mountains and all from a great distance, some of the people never seen this tip of the mountain without snow at all. In their lifetime, they have never seen this mountain, barren mountain, getting exposed to the light. Throughout their lifetime, they have seen always snow-covered mountain, throughout. But now, these people are telling, they are seeing that some of these mountains are without any snow getting this bare area of the rock exposed. To form it, how many years it has taken, and to melt it, it is happening within few years. Over many years, this will result in a rise in sea level that can submerge many coastal areas. So, this melting of the polar ice caps results in a rise in sea level. Remember, it is a known fact. If at all you want to settle in the life, especially I am telling those who are there in the coastal area, if good proposal comes, make it a point to get married to a person who is away from the coastal area. Are you hearing me? Kanisa, Janani, Navya,
Yes, sir.
are you hearing me? What did I say, Navya?
Yes, sir.
What did I say? Kanisa, Rafa, what did I say? There is a fear that the coastal areas they get submerged under the sea in very much near future, and this may happen within another 30 to 40 years. Therefore, make it a point to move away from the coastal belt. Not only here, California, New York, everywhere throughout the world, scientists are cautioning that the township, which is very much nearer at the sea level, which is very much in the sea level, it may get submerged due to melting of the polar ice caps. The total spectrum of changes that global warming can bring about is a subject that is still under active research. How much of this land area get submerged? Very much studies going on. Don't worry, it will not happen overnight. You'll be told, yes, this is going to happen within 10 years, within 5 years, within 3 years, within 2 years, within 1 year. Yes, by that time we can think about leaving that, selling your property there, and going to some other new places where you'll be more safe. Right? Now, this you have to know. Just to note down two things. This El Nino refers to refers to the warm phase. This sentence you take down. La Nina is sometimes referred to as cold phase, and El Nino is referred to as warm phase of Enso. What is Enso? Enso is southern, where is that? El Nino southern oscillation. So here, La Nina is a cold phase and El Nino is warm phase. And this is happening in some area already in the ocean. It is happening in some part of that ocean. Especially it is happening at the East Central Equatorial Pacific. In the Pacific Ocean, East Central Equatorial Pacific region, this is very much happening now. For some continuous 9 to 12 months, it will be the cold phase. For another 9 to 12 months, it is one phase like that. And it is affecting the flora and fauna in that particular area. And first, it is seen to affect the ocean, and then generally, whenever it affects ocean, nearby land also gets affected. Okay? Yes. Now, coming to the next one. How can we control global warming? Yes, before I forget, please look into that. You have to look into the biodiversity questions. It is already there in the Google Classroom. Come well prepared to answer the question in my next class. In the next class, it gets over. This chapter gets over, and I am going to discuss about MCQs pertaining to biodiversity. And in the next class, I will be discussing MCQs pertaining to environmental issues. I request you people to keep keep ready to answer these questions. Okay. How can we control global warming? The measures include cutting down use of fossil fuels. We have to minimize. You may ask why, sir, what is the relation between that? I'll tell you. We have to bring down use of fossil fuel, improving efficiency of energy usage, reducing deforestation, planting trees, and slowing down the growth of human population. You know, whenever the fossil fuel, what is that fossil fuel? Fossil fuel includes your petrol, diesel, all. These, whenever you use more and more fossil fuel, it adds more and more carbon dioxide to the atmosphere. Okay. Reducing deforestation. We are mercilessly cutting the trees. Whenever carbon dioxide are released to the atmosphere, it is these trees, they make use of that carbon dioxide for photosynthesis. They fix the carbon dioxide. So, we have to minimize the usage of fossil fuel. We have to go for improved technique of energy usage. We have to reduce the deforestation. Planting, we have to go for afforestation, planting more and more trees, and slowing down the growth of human population. For most of our problems, the main cause is explosion of human population. Always, we must know that, we must see that with the grace of our elders, we are living now. And we have to live such a atmosphere, such condition for our future generations also. International initiatives are also being taken to reduce the emission of greenhouse gases into the atmosphere. Now, ozone depletion in the stratosphere. You have earlier studied in the chemistry textbook of class 11 about bad ozone formed in the lower atmosphere that harms plants and animals. There are two types of ozone, bad ozone and good ozone. Let us say where we have bad ozone and where you have good ozone. Right? Where you have bad ozone and where you have good ozone. Right? Look here. Ozone occurs in two layers at the atmosphere. The layer closest to the Earth's surface is the troposphere. You must know. I will show in another slide. You must know where is the troposphere, where is the stratosphere, atmosphere, like that. So the layer closest to the Earth's surface is always called a troposphere. Here, ground level ozone or bad ozone that is present at the Earth's surface in the troposphere. Here, ground level or bad ozone is an air pollutant that is harmful to breathe, and this damages crops, trees, and other vegetation. Whatever ozone we have near us, around us, down below, very close to that surface, that is in the troposphere, is a bad ozone, and it damages crops, trees, vegetations, and also it affects our breathing. It is a main ingredient of urban smoke. This ozone is the main content of urban smog. You know, smoke plus fog. The troposphere generally extends to a level of about 6 miles up from the Earth's surface. If this Earth's surface, about 6 miles from the Earth's surface, this is what is called a troposphere. The troposphere generally extends to a level of about 6 miles up, where it meets the second layer, that is the stratosphere. Let us look into that. Look here. This is what I have. Okay, and different books give different data, that the region height and all. This you can have a photo shot or screenshot, or you just note that this is the troposphere. Above the troposphere is the stratosphere. Above the stratosphere is the mesosphere. Above the mesosphere is the thermosphere. Above the thermosphere is exosphere. Exosphere, right? Okay. So this is the atmosphere, and very close to the Earth's surface, you have troposphere. And generally, I said, it extends about to 6 miles. It is said about 12 to 18 kilometers, 0 to 8, whatever it means. The first one. And beyond that, beyond about, say, 20 kilometers, we come across the stratosphere. And whatever ozone you come across here, very close to that surface, is a bad ozone. And whatever you come across here, it is of good ozone. Let us see that. There is good ozone also. This ozone is found in the upper part of the atmosphere called stratosphere. That you have to remember. Bad ozone is found in the troposphere, and good ozone is found in the stratosphere. And it acts as a shield, umbrella. This ozone acts like an umbrella, shield, absorbing ultraviolet radiation from the sun. It will not allow the UV radiation, ultraviolet radiations to come out and touch us. So therefore it is a good ozone. It absorbs ultraviolet radiation from the sun. UV rays, ultraviolet rays, are highly injurious to living organisms, since our DNA and proteins preferentially absorb UV rays. The moment UV rays come, our DNA and proteins absorb UV rays, and its high energy breaks the chemical bonds within these molecules. So they get affected. DNA and proteins, they get affected if at all the UV rays touch our body. The thickness of ozone, this is what is important. The thickness of ozone, how much thickness? The thickness of ozone in a column of air from the ground to the top of the atmosphere is measured in terms of what is known as Dobson unit, DO. Always you must know. Dobson unit is the unit of measurement of 1, 2, 3, 4. Or ozone is measured in terms of Dobson unit, right? Now let us see about this ozone. Ozone gas is continuously formed by reaction of UV rays on molecular oxygen. You know, ozone is O3. So O2 can become O3 easily and also degraded into molecular oxygen in the stratosphere. Ozone can be formed from O2, or it can degrade also. There should be a balance between production and degradation of ozone in the stratosphere. As long as this balance is maintained, no problem. Now, what is the problem? The problem is with regard to thinning of the ozone. We want this ozone umbrella. This is a good ozone. It is protecting us from the UV rays. Of late, the balance has been disrupted. This balance, formation and degradation. This balance has been disrupted due to enhancement of ozone degradation by chlorofluorocarbons, CFCs. This is becoming the main reason for the degradation of the ozone. CFCs, chlorofluorocarbons, find wide use in all refrigerants. Wherever you have that cooling effect, in all that cooling effect, earlier we used to go for CFCs. Chlorofluorocarbons discharged in the lower part of the atmosphere, move upward chlorofluorocarbons, which are discharged at the Earth's surface level, they move upward and reach stratosphere. And in the stratosphere, UV rays act on them, chlorofluorocarbons, and release chlorine atoms. This chlorine degrades ozone, releasing molecular oxygen. This chlorine. So you must know UV rays act on chlorofluorocarbons and release chlorine atoms. Chlorine degrades ozone, releasing molecular oxygen. With these atoms acting merely as catalysts, chlorine atoms are not consumed in the reaction. So what is most important here is that here the chlorofluorocarbons are acted upon by UV rays and make chlorine atoms to get released. This chlorine degrades ozone. So we have to see that ozone thickness has to be maintained. That is most important. Formation, production, and degradation should be in a balanced condition. What is happening in nowadays is that this ozone thickness is getting reduced. The ozone layer is becoming thin and thin, and we have to prevent it. How that, what measures have been taken? Hence, whatever chlorofluorocarbons are added to the stratosphere, they have permanent and continuing effects on ozone level. So we have to minimize this. Usage of this chlorofluorocarbon has to be totally stopped. Although ozone depletion is occurring widely in the stratosphere, the depletion is particularly marked over Antarctic region. In some part, it is very prominently seen. And you might have heard about ozone hole. This has resulted in formation of large area of a thinner ozone layer, commonly called ozone hole. Always ask a question, what is ozone hole? Ozone hole is nothing but the area where the ozone is very thin, especially this is the region nearer to the Antarctic. So this, look here. Right? Ozone hole is the area. This is what ozone hole is, the area above the Antarctica, shown in purple color, right? Where the ozone layer is the thinnest. Ozone thickness is given in terms of unit. I already mentioned earlier. Now, what is ultraviolet radiation? This is just for your information. You must know. Many times we say UV radiation, they are harmful. Is it all type of that? Is there any different types of UV radiation? Yes. Ultraviolet radiation is one form of radiant energy coming from the sun. If at all this touches the DNA, it breaks down the bond between DNA and the protein. Then it's harmful. The various forms of energy or radiation are classified according to wavelength, measured in nanometer. Look here. The shorter the wavelength, the more energetic is the radiation. Shorter the wavelength, more energy is the radiation. In order of decreasing energy, the principal forms of radiations are gamma rays, X-rays, UV rays. In the order of decreasing energy, I said shorter the wavelength, more is the energetic radiation. So you have here three categories of UV radiation. Just remember, UVA, UVB, UVC. UVA, this part, especially this part, you please note down, there are three types of UV radiation. This part, UVA, it is between 320 and 400 nanometer. Okay, wavelength. UVB, between 280 and 320 nanometer. UVC, between 200 and 280 nanometer. You tell me which is more energetic radiation here? Most energetic radiation?
UVC.
UVC. UVC is the most energetic radiation when compared to UVA B. Okay. Now, just to make you to know, right? How harmful is UV? I have told you they are just breaking the bond in the DNA and protein. Generally, shorter the wavelength, more biologically damaging UV radiation, energetic it is, can be if it reaches the earth in sufficient quantity. UVA is the least damaging. UVA is the least damaging. UVA is the least damaging, right? And UVA is the least damaging form of UV radiation and reaches the earth in greatest quantity. Most UVA rays pass right to the ozone layer in the stratosphere. UVB radiation can be very harmful. UVB radiation. Fortunately, most of the sun's UVB radiation is absorbed by the ozone in the stratosphere itself. UVC radiation is potentially most damaging because it is very energetic. Fortunately, all UVA, UVC is absorbed by oxygen and ozone in the stratosphere. Therefore, we always bother about UVA, right? UVA. Because UVB radiation, now, if at all this ozone layer thickness is declines, then these UVB and UVC affect the earth. Clear? Understood? Hello? Vishwita? Harshvardhan?
Yes, sir.
Shall you go ahead?
Yes, sir.
But UVB damages DNA and mutation may occur. Whenever ozone thickness reduces, UVB and UVC, they can affect more. UVB damages DNA and mutation may occur. It causes aging of skin, damage to skin cells, and various types of skin cancer. In human eye, cornea absorbs UVB radiation, and a high dose of UVB causes inflammation of cornea called snow blindness or cataract, etc. Such exposure may permanently damage the cornea. So this is with regard to three types. You remember UVA, UVB, UVC. UVC is more energetic than UVB or UVA. Fortunately, UVB and UVC, because of the ozone, it is not striking the atmosphere, otherwise they are quite damaging. UVA is the only one that you come across, but it is not that much harmful, right? Recognizing the deleterious effects of ozone depletion, an international treaty known as Montreal Protocol, very important. You must know which protocol is related to what. You heard about Earth Summit. It is concerned with what? Earth Summit. Have you heard about Earth Summit?
Yes, sir.
Concerned with what?
For the conservation of biodiversity.
Biodiversity, conserving biodiversity. Recognizing the deleterious effects of the ozone depletion, an international treaty known as the Montreal Protocol was signed at Montreal, Canada in 1987 to control the emission of ozone depleting substance. Now, what is the need of the day? The need of the day is that we should control the emission of substances which deplete ozone. So, for that purpose, good number of countries joined together and they have signed an agreement. And this is what is called Montreal Protocol. Montreal Protocol is concerned with minimizing the usage of ozone depleting substance. Subsequently, many more efforts have been made and protocols have laid down definite roadmaps separately for developing and developing countries for reducing the emission of CFCs, chlorofluorocarbon. And now, whenever you are going to buy these refrigerators, you will be seeing a label there. Have you seen that label? Have you seen that writing in many of these refrigerators? Have you seen that? There will be labeling called CFC free of CFCs, chlorofluorocarbon. They have gone for alternative technology. So the Montreal Protocol on substances that are depleted ozone layer, the protocol to the Vienna Convention is an international treaty designed to protect the ozone layer by phasing out the production of numerous substances that are responsible for ozone depletion. By phasing out, by keeping out the production of numerous substances that are responsible for ozone depletion. It was agreed on 16 September 1987 and entered into force on 16 September 1989 following a first meeting at Helsinki, May 1980. Since then, it has undergone 8 revisions. Once it started in 1987, 8 revisions, 1990, 91, 92, 93, 95, 97, 98, 99, 2016. These many times people have met to take stock of what is happening to the ozone. So, as a result of the international agreement, the ozone hole in Antarctica is slowly recovering. Climate projections indicate that the ozone layer will return to 1980 levels between 2050 and 2070. That means we are reducing drastically the use of substances which are depleting ozone. Due to its widespread adoption and implementation, it has been hailed as an example of exceptional international cooperation, with Kofi Annan quoting that, saying that perhaps the single most successful international agreement to date has been Montreal Protocol. People never bothered about any other issues, how much they have bothered about ozone depletion. So this is the only protocol. It is a gathering. It is the get together of the countries to see that the ozone thinning is getting to normal, or it is getting improved. So this, what you have to say, degradation by improper resource utilization maintenance. I will take up this one in tomorrow's class, and a little bit with this tomorrow's class that this particular part gets over, and I will be starting with the discussion on biodiversity MCQs, and also later that of environment issues. I shall post that environmental issues MCQs in uh, in short. Okay. Do you have any doubts? Come on.